Hi, Joanna. Good to meet you. Now, before we discuss your new research project, I'd like to hear something about the psychology study you did last year for your master's degree. So, how did you choose your subjects for that?
Well, I had 6 subjects, all professional musicians and all female. 3 were violinists, and there was also a cello player and a pianist and a flute player. They were all very highly regarded in the music world, and they'd done quite extensive tours in different continents, and quite a few had won prizes and competitions as well.
And they were quite young, weren't they?
Yes, between 25 and 29. The mean was 27.8. I wasn't specifically looking for artists who'd produced recordings, but this is something that's just taken for granted these days, and they all had.
Right. Now, you collected your data through telephone interviews, didn't you?
Yes. I realised if I was going to interview leading musicians, it'd only be possible over the phone because they're so busy. I recorded them using a telephone recording adapter. I'd been worried about the quality, but it worked out all right. I managed at least a 30-minute interview with each subject, sometimes longer.
Did doing it on the phone make it more stressful?
I'd thought it might. It was all quite informal, though, and in fact they seemed very keen to talk. And I don't think using the phone meant I got less rich data. Rather the opposite, in fact.
Interesting. And you were looking at how performers dress for concert performances?
That's right. My research investigated the way players see their role as a musician and how this is linked to the type of clothing they decide to wear. But that focus didn't emerge immediately. When I started, I was more interested in trying to investigate the impact of what was worn on those listening, and also whether someone like a violinist might adopt a different style of clothing from, say, someone playing the flute or the trumpet.
It's interesting that the choice of dress is up to the individual, isn't it?
Yes, you'd expect there to be rules about it in orchestras, but that's quite rare.
You only had women performers in your study. Was that because male musicians are less worried about fashion?
I think a lot of the men are very much influenced by fashion, but in social terms, the choices they have are more limited. They'd really upset audiences if they strayed away from quite narrow boundaries.
Now, popular music has quite different expectations. Did you read Mike Frost's article about the dress of women performers in popular music?
No.
Well, he points out that a lot of female singers and musicians in popular music tend to dress down in performances and wear less feminine clothes, like jeans instead of skirts. And he suggests this is because otherwise they'd just be discounted as trivial.
But you could argue they're just wearing what's practical. I mean, a pop music concert is usually a pretty energetic affair.
Yes, he doesn't make that point, but I think you're probably right. I was interested by the effect of the audience at a musical performance when it came to the choice of dress.
The subjects I interviewed felt this was really important. It's all to do with what we understand by performance as a public event. They believed the audience had certain expectations, and it was up to them as performers to fulfil these expectations, to show a kind of esteem.
They weren't afraid of looking as if they'd made an effort to look good.
I think in the past, the audience would have had those expectations of one another too, but that's not really the case now. Not in the UK, anyway.
No.
And I also got interested in what sports scientists are doing too with regard to clothing.
Musicians are quite vulnerable physically, aren't they? Because the movements they carry out are very intensive and repetitive. So I'd imagine some features of sports clothing could safeguard the players from the potentially dangerous effects of this sort of thing.
Yes, but musicians don't really consider it. They avoid clothing that obviously restricts their movements, but that's as far as they go.
Anyway, coming back to your own research, do you have any idea where you're going from here?
I was thinking of doing a study using an audience, including...
I've brought my notes on our biology field trip to Rocky Bay, Colin, so we can work on our report on the research we did together.
OK. I've got mine too. Let's look at the aims of the trip first.
Right. What did you have?
I just put something about getting experience of the different sorts of procedures used on a field trip. But we need something about what causes different organisms to choose particular habitats.
I agree. And something about finding out how to protect organisms in danger of dying out.
In our aims? But we weren't really looking at that.
I suppose not. OK, now there's the list of equipment we all had to bring on the field trip. What did they tell us to bring a ruler for?
It was something about measuring the slope of the shore. But of course we didn't need it because we were measuring wind direction and we'd brought the compass for that.
But not the piece of string to hold up in the air. Didn't Mr. Blake make a fuss about us leaving that behind?
Yeah, he does go on. Anyway, it was easy to get one from another of the students.
Now, the next section's the procedure. I sent you the draft of that.
Yeah, it was clear, but I don't think we need all these details of what time we left and what time we got back and how we divided up the different research tasks.
OK, I'll look at that again.
Then we have to describe our method of investigation in detail. So let's begin with how we measured wave speed. I was surprised how straightforward that was.
I'd expected us to have some sort of high-tech device, not just stand there and count the number of waves per minute. Not very precise, but I suppose it was good enough. But the way we measured the amount of salt was interesting.
In the water from the rock pools?
Yeah. Oh, I wanted to check the chemicals we used in the lab when we analysed those samples. Was it potassium chromate and silver nitrate?
That's right.
OK. And we need the map of the seashore. You just left that to me. And I had to do it while the tide was low. Well, that was OK, but the place I started it from was down on the beach. Then I realised I should have gone up higher to get better visibility, so I had to start all over again. But at least I'd got the squared paper, or I'd have had problems drawing it all to scale.
Yeah, it looks good. We could get a map of the region off the internet and see if we need to make any changes.
I had a look, but I couldn't find anything. But you took some pictures, didn't you?
Yeah, I'll email you them if you want.
OK, I'll make my amendments using those. Then I can scan it into our report. Great! Now, when we get to our findings, I thought we could divide them up into the different zones we identified on the shore and the problems organisms face in each zone. So for the highest area...
The splash zone?
Yeah. We found mostly those tiny shellfish that have strong, hard shells that act as protection.
But not from other organisms that might eat them, predators?
No, that's not the main danger for them, but the shells prevent them from drying out because they're in the open air for most of the time.
Right. And since they're exposed, they need to be able to find some sort of shelter or cover themselves up so they don't get too hot. Then in the middle and lower zones, nearer the sea, we need to discuss the effects of wave action.
Yes, and how organisms develop structures to prevent themselves from being swept away or even destroyed by being smashed against the rocks.
I haven't done anything on the geological changes. I don't know what to put for that.
No, we weren't concentrating on that. Maybe we need to find some websites.
Good idea. I've got the lecture notes from Mr. Blake's geology course, but they're too general. But we could ask him which books on our reading list might be most helpful.
Right. OK. Now, I did a draft of the section of sources of possible error in our research, but I don't know if you agree. For example, the size of the sample and whether it's big enough to make any general conclusions from. But I thought, actually, we did have quite a big sample.
We did. And our general method of observation seemed quite reliable. But we might not be all that accurate as far as the actual numbers go.
Yeah, we might have missed some organisms, if they were hiding under a rock, for example. I wasn't sure about the way we described their habitats. I decided it was probably OK.
Yeah, and the descriptions we gave of the smaller organisms, they weren't very detailed, but they were adequate in this context. I'm not sure we identified all the species correctly, though.
OK, we'd better mention that. Now, how are we going to...
Hello, Trevor.
Hello, Stephanie. You said you wanted to talk about the course I'm taking on literature for children.
That's right. I'm thinking of doing it next year, but I'd like to find out more about it first.
OK, well, as you probably know, it's a one-year course. It's divided into 6 modules, and you have to take all of them. One of the most interesting ones, for me at least, was about the purpose of children's literature.
You mean whether it should just entertain children or should be educational as well?
Right, and whether the teaching should be factual, giving them information about the world, or ethical, teaching them values. What's fascinating is that the writer isn't necessarily conscious of the message they're conveying. For instance, a story might show a child who has a problem as a result of not doing what an adult has told them to do, implying that children should always obey adults.
Oh, I see what you mean.
That module made me realise how important stories are. They can have a significant effect on children as they grow up. Actually, it inspired me to have a go at it myself, just for my own interest. I know I can't compete with the really popular stories, like the Harry Potter books. They're very good. And even young kids like my 7-year-old niece love reading them.
I'm very interested in illustrations in stories. Is that covered in the course?
Yes, there's a module on pictures and how they're sometimes central to the story.
That's good. I remember some frightening ones I saw as a child, and I can still see them vividly in my mind years later. Pictures can be so powerful, just as powerful as words. I've always enjoyed drawing, so that's the field I want to go into when I finish the course. I bet that module will be really helpful.
I'm sure it will. We also studied comics in that module, but I'm not convinced of their value, not compared with books. One of the great things about words is that you use your imagination, but with a comic you don't have to.
But children are so used to visual input on TV, video games and so on. There are plenty of kids who wouldn't even try to read a book, so I think comics can serve a really useful purpose.
You mean it's better to read a comic than not to read at all? Yes, I suppose you're right. I just think it's sad when children don't read books.
What about books for girls and books for boys? Does the course go into that?
Yes, there's a module on it. For years, lots of stories, in English at least, assumed that boys went out and did adventurous things and girls stayed at home and played with dolls. I was amazed how many books were targeted at just one sex or the other. Of course, this reflects society as it is when the books are written.
That's true. So it sounds as though you think it's a good course.
Definitely. Have you been reading lots of children's stories to help you decide whether to take the course?
Yeah, I've gone as far back as the late 17th century, though I know there were earlier children's stories.
So does that mean you've read Perrault's fairy tales, Cinderella, the Sleeping Beauty and so on?
Yes, they must be important because no stories of that type had been written before. These were the first. Then there's the Swiss Family Robinson.
I haven't read that.
The English name makes it sound as though Robinson is the family's surname, but a more accurate translation would be the Swiss Robinsons, because it's about a Swiss family who are shipwrecked, like Robinson Crusoe in the novel of a century earlier.
Well, I never knew that.
Have you read Hoffmann's The Nutcracker and the Mouse King?
Wasn't that the basis for Tchaikovsky's ballet, The Nutcracker?
That's right. It has some quite bizarre elements.
I hope you've read Oscar Wilde's The Happy Prince. It's probably my favourite children's story of all time.
Oh, mine too. And it's so surprising because Wilde is best known for his plays, and most of them are very witty, but The Happy Prince is really moving. I struggled with Tolkien's The Lord of the Rings. 3 long books, and I gave up after 1.
It's extremely popular, though.
Yeah, But whereas something like The Happy Prince just carried me along with it, The Lord of the Rings took more effort than I was prepared to give it.
I didn't find that. I love it.
Another one I've read is Warhorse.
Oh yes, it's about the First World War, isn't it? Hardly what you'd expect for a children's story.
Exactly, but it's been very successful. Have you read any...
So, how are you getting on with your teaching practice at the high school, Joe?
Well, I've been put in charge of the school marching band, and it's quite a responsibility. I'd like to talk it over with you.
Go ahead. You better start by giving me a bit of background.
Okay. Well, the band has students in it from all years. So they're aged 11 to 18, and there are about 50 of them altogether. It's quite a popular activity within the school. I've never worked with a band of more than 20 before, and this is very different.
I can imagine.
They aren't really good enough to enter national band competitions, but they're in a regional one later in the term. Even if they don't win, and I don't expect them to, hopefully it'll be an incentive for them to try and improve.
Yes, hopefully.
Well, now the town council's organizing a carnival in the summer, and the band has been asked to perform. If you ask me, they aren't really up to it yet, and I need to get them functioning better as a band, and in a very short time.
Have you been doing anything with them? Apart from practicing the music, I mean.
I played a recording I came across of a drummer talking about how playing in a band had changed his life. I think it was an after-dinner speech. I thought it was pretty inspiring, because being in the band had stopped him from getting involved in crime. The students seemed to find it interesting, too.
That's good.
I'm planning to show them that old film from the 1940s, Strike Up the Band, and talk about it with the students. What do you think?
Good idea. As it's about a school band, it might make the students realize how much they can achieve if they work together.
That's what I've got in mind. I'm hoping I can take some of the band to a parade that's going to take place next month. A couple of marching bands will be performing, and the atmosphere should be quite exciting. It depends on whether I can persuade the school to hire a coach or two to take us there.
They sound like good ideas to me.
Thanks. Can I tell you about a few people in the band who I'm finding it quite difficult to cope with? I'm sure you'll have some ideas about what I can do.
Go ahead.
There's a flautist who says she loves playing in the band. We rehearse twice a week after school, but she's hardly ever there. Then she looks for me the next day and gives me a very plausible reason. She says she had to help her mother, or she's been ill, but to be honest, I don't believe her.
Oh dear. Any more students with difficulties?
Plenty. There's a trumpeter who thinks she's the best musician in the band, though she certainly isn't. She's always saying what she thinks other people should do, which makes my job pretty difficult.
She sounds a bit of a nightmare.
You can say that again. One of the trombonists has got an impressive sense of rhythm and could be an excellent musician, except that he has breathing difficulties, and he doesn't really have enough breath for the trombone. He'd be much better off playing percussion, for instance, but he refuses to give up, so he ends up only playing half the notes.
I suppose you have to admire his determination.
Maybe. One of the percussionists isn't too bad, but he never seems to interact with other people, and he always rushes off as soon as the rehearsal ends. I don't know if there are family reasons or what, but it isn't good in a band, where people really need to feel they're part of a group. There are others too, but at least that gives you an idea of what I'm up against. Do you have any thoughts about what I can do, Lizzie?
So, Rosie and Martin, let's look at what you've got for your presentation on woolly mammoths.
OK, we've got a short outline here.
Thanks. So, it's about a research project in North America.
Yes, but we thought we needed something general about woolly mammoths in our introduction. to establish that they were related to our modern elephant, and they lived thousands of years ago in the last ice age.
Maybe we could show a video clip of a cartoon about mammoths, but that'd be a bit childish. Or we could have a diagram. It could be a timeline to show when they lived, with illustrations.
Or we could just show a drawing of them walking in the ice. No, let's go with your last suggestion.
Good. Then you're describing the discovery of the Mammoth Tooth on St. Paul's Island in Alaska, and why it was significant.
Yes, the tooth was found by a man called Russell Graham. He picked it up from under a rock in a cave. He knew it was special. For a start, it was in really good condition, as if it had been just extracted from the animal's jawbone. Anyway, they found it was 6,500 years old.
So why was that significant?
Well, the mammoth bones previously found on the North American mainland were much less recent than that, so this was really amazing.
Then we're making an animated diagram to show the geography of the area in prehistoric times. So, originally, St. Paul's Island wasn't an island. It was connected to the mainland, and mammoths and other animals, like bears, were able to roam around the whole area.
Then the climate warmed up and the sea level began to rise, and the island got cut off from the mainland. So those mammoths on the island couldn't escape. They had to stay on the island.
And in fact, the species survived there for thousands of years after they'd become extinct on the mainland.
So why do you think they died out on the mainland?
No one's sure.
Anyway, next we'll explain how Graham and his team identified the date when the mammoths became extinct on the island. They concluded that the extinction happened 5,600 years ago, which is a very precise time for a prehistoric extinction. It's based on samples they took from mud at the bottom of a lake on the island. They analysed it to find out what had fallen in over time, bits of plants, volcanic ash, and even DNA from the mammoths themselves. It's standard procedure, but it took nearly 2 years to do.
So why don't you quickly go through the main sections of your presentation and discuss what actions needed for each part?
OK. So for the introduction, we're using a visual. So once we've prepared that, we're done.
I'm not sure. I think we need to write down all the ideas we want to include here, not just rely on memory. How we begin the presentation is so important.
You're right.
The discovery of the mammoth tooth is probably the most dramatic part, but we don't have that much information, only what we got from the online article. I thought maybe we could get in touch with the researcher who led the team and ask him to tell us a bit more.
Great idea. What about the section with the initial questions asked by the researchers? We've got a lot on that, but we need to make it interesting.
We could ask the audience to suggest some questions about it and then see how many of them we can answer. I don't think it would take too long.
Yes, that would add a bit of variety.
Then the section on further research carried out on the island, analysing the mud in the lake. I wonder if we've actually got too much information here. Should we cut some?
I don't think so, but it's all a bit muddled at present.
Yes. Maybe it would be better if it followed a chronological pattern.
I think so. The findings and possible explanations section is just about ready, but we need to practice it so we're sure it won't overrun.
I think it should be okay, but yes, let's make sure.
In the last section, relevance to the present day, you've got some good ideas, but this is where you need to move away from the ideas of others and give your own viewpoint.
OK, we'll think about that. Now, shall we show you some of the...
OK, so what I'd like you to do now is to talk to your partner about your presentations on urban planning. You should have done most of the reading now, so I'd like you to share your ideas and talk about the structure of your presentation and what you need to do next.
OK, Rob, I'm glad we chose quite a specific topic. Cities built next to the sea. It made it much easier to find relevant information.
Yeah, and cities are growing so quickly. I mean, we know that more than half the world's population lives in cities now.
Yeah, though that's all cities, not just ones on the coast. But most of the biggest cities are actually built by the sea. I'd not realised that before.
Nor me. And what's more, a lot of them are built at places where rivers come out into the sea, but apparently this can be a problem.
Why?
Well, as the city expands, agriculture and industry tend to spread further inland along the rivers, and so agriculture moves even further inland up the river. That's not necessarily a problem, except it means more and more pollutants are discharged into the rivers.
So these are brought downstream to the cities?
Right. Did you read that article about Miami on the east coast of the USA?
No.
Well, apparently back in the 1950s, they built channels to drain away the water in case of flooding.
Sounds sensible.
Yeah, they spent quite a lot of money on them, but what they didn't take into account was global warming. So they built the drainage channels too close to sea level, and now sea levels are rising, they're more or less useless. If there's a lot of rain, the water can't run away. There's nowhere for it to go. The whole design was faulty.
So what are the authorities doing about it now?
I don't know. I did read that they're aiming to stop disposing of wastewater into the ocean over the next 10 years.
But that won't help with flood prevention now, will it?
No, really, they just need to find the money for something to replace the drainage channels in order to protect against flooding now. But in the long term, they need to consider the whole ecosystem.
Right. Really, though, coastal cities can't deal with their problems on their own, can they? I mean, they've got to start acting together at an international level instead of just doing their own thing.
Absolutely. The thing is, everyone knows what the problems are, and environmentalists have a pretty good idea of what we should be doing about them, so they should be able to work together to some extent. But it's going to be a long time before countries come to a decision on what principles they're prepared to abide by.
Yeah, if they ever do. So, I think we've probably got enough for our presentation. It's only 15 minutes.
OK, so I suppose we'll begin with some general historical background about why coastal cities were established. But we don't want to spend too long on that. The other students will already know a bit about it. It's all to do with communications and so on.
Yes. We should mention some geographical factors, things like wetlands and river estuaries and coastal erosion and so on. We could have some maps of different cities with these features marked.
On a handout, you mean? Or some slides everyone can see?
Yeah, that'd be better.
It'd be good to go into past mistakes in a bit more detail. Did you read that case study of the problems there were in New Orleans with flooding a few years ago?
Yes, we could use that as the basis for that part of the talk. I don't think the other students will have read it, but they'll remember hearing about the flooding at the time.
OK. So that's probably enough background.
So then we'll go on to talk about what action's been taken to deal with the problems of coastal cities.
OK. What else do we need to talk about? Maybe something on future risks, looking more at the long term if populations continue to grow?
Yeah, we'll need to do a bit of work there. I haven't got much information, have you?
No, we'll need to look at some websites. Shouldn't take too long.
OK. And I think we should end by talking about international implications. Maybe we could ask people in the audience. We've got people from quite a lot of different places.
That'd be interesting, if we have time, yes. So now, shall we go on?
As we saw in the last lecture, a major cause of climate change is the rapid rise in the level of carbon dioxide in the atmosphere over the last century. If we could reduce the amount of CO2, perhaps the rate of climate change could also be slowed down. One potential method involves enhancing the role of the soil that plants grow in with regard to absorbing CO2. Ratan Lal, a soil scientist from Ohio State University in the USA, claims that the world's agricultural soils could potentially absorb 13% of the carbon dioxide in the atmosphere, the equivalent of the amount released in the last 30 years, and research is going on into how this might be achieved. Lal first came to the idea that soil might be valuable in this way, not through an interest in climate change, but rather out of concern for the land itself and the people dependent on it. Carbon-rich soil is dark, crumbly and fertile, and retains some water. But erosion can occur if soil is dry, which is a likely effect if it contains inadequate amounts of carbon. Erosion is of course bad for people trying to grow crops or breed animals on that terrain. In the 1970s and 80s, Lal was studying soils in Africa so devoid of organic matter that the ground had become extremely hard, like cement. There he met a pioneer in the study of global warming who suggested that carbon from the soil had moved into the atmosphere. This is now looking increasingly likely. Let me explain. For millions of years, carbon dioxide levels in the atmosphere have been regulated, in part, by a natural partnership between plants and microbes, tiny organisms in the soil. Plants absorb CO2 from the air and transform it into sugars and other carbon-based substances. While a proportion of these carbon products remain in the plant, some transfer from the roots to fungi and soil microbes, which store the carbon in the soil. The invention of agriculture some 10,000 years ago disrupted these ancient soil-building processes and led to the loss of carbon from the soil. When humans started draining the natural topsoil and ploughing it up for planting, they exposed the buried carbon to oxygen. This created carbon dioxide and released it into the air. And in some places, grazing by domesticated animals has removed all vegetation, releasing carbon into the air. Tons of carbon have been stripped from the world's soils, where it's needed, and pumped into the atmosphere. So, what can be done? Researchers are now coming up with evidence that even modest changes to farming can significantly help to reduce the amount of carbon in the atmosphere. Some growers have already started using an approach known as regenerative agriculture. This aims to boost the fertility of soil and keep it moist through established practices. These include keeping fields planted all year round and increasing the variety of plants being grown. Strategies like these can significantly increase the amount of carbon stored in the soil, so agricultural researchers are now building a case for their use in combating climate change. One American investigation into the potential for storing CO2 on agricultural lands is taking place in California. Soil scientist Wendy Silver of the University of California, Berkeley, is conducting a first-of-its-kind study on a large cattle farm in the state. She and her students are testing the effects on carbon storage of the compost that is created from waste, both agricultural, including manure and corn stalks, and waste produced in gardens, such as leaves, branches, and lawn trimmings. In Australia, soil ecologist Christine Jones is testing another promising soil enrichment strategy. Jones and 12 farmers are working to build up soil carbon by cultivating grasses that stay green all year round. Like composting, the approach has already been proved experimentally. Jones now hopes to show that it can be applied on working farms and that the resulting carbon capture can be accurately measured. It's hoped in the future that projects such as these will demonstrate the role that farmers and other land managers can play in reducing the harmful effects of greenhouse gases. For example, in countries like the United States, where most farming operations use large applications of fertilizer, Changing such long-standing habits will require a change of system. Ratan Lal argues that farmers should receive payment, not just for the corn or beef they produce, but also for the carbon they can store in their soil. Another study being carried out.
We've been discussing the factors the architect has to consider when designing domestic buildings. I'm going to move on now to consider the design of public buildings, and I'll illustrate this by referring to the new Taylor Concert Hall that's recently been completed here in the city. So, as with a domestic building, when designing a public building, an architect needs to consider the function of the building. For example, is it to be used primarily for entertainment, or for education, or for administration? The second thing the architect needs to think about is the context of the building. This includes its physical location, obviously, but it also includes the social meaning of the building, how it relates to the people it's built for. And finally, for important public buildings, the architect may also be looking for a central symbolic idea on which to base the design, a sort of metaphor for the building and the way in which it is used. Let's look at the new Taylor Concert Hall in relation to these ideas. The location chosen was a site in a run-down district that has been ignored in previous redevelopment plans. It was occupied by a factory that has been empty for some years. The whole area was some distance from the high-rise office blocks of the central business district and shopping centre, but it was only 1 kilometre from the ring road. The site itself was bordered to the north by a canal, which had once been used by boats bringing in raw materials when the area was used for manufacturing. The architect chosen for the project was Tom Harrison. He found the main design challenge was the location of the site in an area that had no neighbouring buildings of any importance. To reflect the fact that the significance of the building in this quite run-down location was as yet unknown, he decided to create a building centred around the idea of a mystery, something whose meaning still has to be discovered. So, how was this reflected in the design of the building? Well, Harrison decided to create pedestrian access to the building and to make use of the presence of water on the site. As people approach the entrance, they therefore have to cross over a bridge. He wanted to give people a feeling of suspense as they see the building first from a distance and then close up. And the initial impression he wanted to create from the shape of the building as a whole was that of a box. The first side that people see, the southern wall, is just a high, flat wall uninterrupted by any windows. This might sound off-putting, but it supports Harrison's concept of the building, that the person approaching is intrigued and wonders what will be inside. And this flat wall also has another purpose. At night time, projectors are switched on, and it functions as a huge screen onto which images are projected. The auditorium itself seats 1,500 people. The floors supported by 10 massive pads. These are constructed from rubber and so are able to absorb any vibrations from outside and prevent them from affecting the auditorium. The walls are made of several layers of honey-coloured wood, all sourced from local beech trees. In order to improve the acoustic properties of the auditorium and to amplify the sound, they are not straight, they are curved. The acoustics are also adjustable according to the size of orchestra and the type of music being played. In order to achieve this, there are 9 movable panels in the ceiling above the orchestra, which are all individually motorised. And the walls also have curtains, which can be opened or closed to change the acoustics. The reaction of the public to the new building has generally been positive. However, the evaluation of some critics has been less enthusiastic. In spite of Harrison's efforts to use local materials, they criticise the style of the design as being international rather than local, and say it doesn't reflect features of the landscape or society for which it is built.
Producing enough energy to meet our needs has become a serious problem. Demand is rising rapidly because of the world's increasing population and expanding industry. Burning fossil fuels like gas, coal and oil seriously damages the environment, and they'll eventually run out. For a number of years now, scientists have been working out how we can derive energy from renewable sources, such as the sun and wind, without causing pollution. Today, I'll outline marine renewable energy, also called ocean energy, which harnesses the movement of the oceans. Marine renewable energy can be divided into three main categories: wave energy, tidal energy, and ocean thermal energy conversion. And I'll say a few words about each one. First, wave energy. Numerous devices have been invented to harvest wave energy, with names such as Wave Dragon, the Penguin, and Mighty Whale, and research is going on to try and come up with a really efficient method. This form of energy has plenty of potential, as the source is constant, and there's no danger of waves coming to a standstill. Electricity can be generated using onshore systems, using a reservoir, or offshore systems. But the problem with ocean waves is that they're erratic, with the wind making them travel in every direction. This adds to the difficulty of creating efficient technology. Ideally, all the waves would travel smoothly and regularly along the same straight line. Another drawback is that sand and other sediment on the ocean floor might be stopped from flowing normally, which can lead to environmental problems. The second category of marine energy that I'll mention is tidal energy. One major advantage of using the tide rather than waves as a source of energy is that it's predictable. We know the exact times of high and low tides for years to come. For tidal energy to be effective, the difference between high and low tides needs to be at least 5 meters, and this occurs naturally in only about 40 places on Earth. But the right conditions can be created by constructing a tidal lagoon, an area of seawater separated from the sea. One current plan is to create a tidal lagoon on the coast of Wales. This will be an area of water within a bay at Swansea, sheltered by a U-shaped breakwater, or dam, built out from the coast. The breakwater will contain 16 hydro turbines, and as the tide rises, water rushes through the breakwater, activating the turbines, which turn a generator to produce electricity. Then, for 3 hours as the tide goes out, the water is held back within the breakwater, increasing the difference in water level until it's several meters higher within the lagoon than in the open sea. Then, in order to release the stored water, gates in the breakwater are opened. It pours powerfully out of the lagoon, driving the turbines in the breakwater in the opposite direction and again generating thousands of megawatts of electricity. As there are 2 high tides a day, this lagoon scheme would generate electricity 4 times a day, every day, for a total of around 14 hours in every 24, and enough electricity for over 150,000 homes. This system has quite a lot in its favour. Unlike solar and wind energy, it doesn't depend on the weather. The turbines are operated without the need for fuel, so it doesn't create any greenhouse gas emissions, and very little maintenance is needed. It's estimated that electricity generated in this way will be relatively cheap, and that manufacturing the components would create more than 2,000 jobs, a big boost to the local economy. On the other hand, there are fears that lagoons might harm both fish and birds, for example by disturbing migration patterns and causing a build-up of silt, affecting local ecosystems. There are other forms of tidal energy, but I'll go on to the third category of marine energy, ocean thermal energy conversion. This depends on there being a big difference in temperature between surface water and the water a couple of kilometres below the surface, and this occurs in tropical coastal areas. The idea is to bring cold water up to the surface using a submerged pipe. The concept dates back to 1881, when